All right, so questions that we want to look at today is on sketching the graph of a cubic function. And we've been given below, but they're also telling us to indicate or show clearly the points where the graph crosses or touches the coordinate axis. They're telling us to show where it crosses or touches the what? Coordinate axis. Well, that is very essential for us to understand. So the cubic function, um, okay, will be of the form, just a minute, cubic function, okay, to get this thing straight, okay, ish, don't know what's going on with this, my device, okay, saying a cubic function is going to be of the form like that and like that. So what this means is this function which we're going to have is going to cut this graph. Remember, this is the y, that's the x. It's going to cut this graph at, so in the x-axis, it's going to cut it 3 times. Thus, it's a cubic function, meaning it has what? Highest degree of what? Of 3. Then it cuts in the y once like that, as indicated. It can either be down or up like that, as it has been what? Has been shown. So I'll go straight into trying to answer the question as it comes. So cubic functions are more involving when it comes to graphing than the normal quadratic functions or quadratic equations. So you have them being given like this. So they tell you y is equal to, okay, what is happening here? Okay, so you have y to be equal to x cubed plus x squared minus 8x minus 12. So the first step that you want to do is to factorize this. So you've seen that when we had that drawn that kind of graph, we said that the x-axis, or I mean the graph, is going to cut at 3 points. It's going to cut the x-axis at 3 points. So that means that it's going to have how many intercepts? It's going to have how many x-intercepts? If it's cut, it's having how many?
3.
3. So it will have 3 x-intercepts. To have a maximum of what? 3 x-intercepts. So these are going to be the points where that graph is going to cut the x-axis. So maximum you have is what? Is 3. But we'll see that that's not always the case. Sometimes you can only have what? You can only have 2. Yeah, so you have 3 and you have a what? A y-intercept. So that's the point where the graph cuts the y-axis. Then what else do we need? So remember, even like in the previous case where we were calculating or for the quadratic function, we had turning points. And in a quadratic uh, equation or function, we only had we only had 1 turning point. So now this here, because the curve goes up and then down like that, we're going to have 2 what? Turning points. Usually have what? 2 turning points. 2 turning points, and that usually involves both a maximum and a minimum turning point. Both have a maximum and a minimum turning point. Well, these are not the easiest to get, like the way we had the first one where we could get them. Remember, in a quadratic function, if you factorize it, that is, you say a, that's minus, what did we have here? B over 2a, something like this, minus, then you had the value here. I'll just put p to represent that whole thing that is here. Yeah, but then for a turning point of a quadratic function or equation, you just get this here. For quadratic, you get this, then multiply it by negative. So you have b over 2a. You multiply this by negative, then you just get that the way it is, and this would be a turning point. But we see in this case that it would be quite a bit involving than just this usual one. So what do we do here? Let's go direct into our equation. So first of all, we want to factorize this. So we want to use the rational root test in order to find what? To find the factor of this. So that rational root test, if I say this here, the coefficient of this x cubed be my a, then I say this here, constant be my b, then I want to say that I want to divide a b over a, and I want to divide all the possible factors of b and what and a. So that will be plus minus of those factors, plus minus. So I have 1, plus minus 2, plus minus 3, plus minus 4, and plus minus what? 6, and plus minus 12. So those are the ones for B. Then for A, since it's just 1, so it's plus minus 1. And of course, if you divide, you just remain with what's on top, where you're just saying plus minus 1, plus minus 2, plus minus 3, plus minus 4, then you have plus minus 6, then plus minus 12. So you get that there. Okay, then from there, what I want to do is to replace these. I have to test. So I want to see which one will give me what? Will give me 0 when I replace x here. So let's say I get the factor 1 and replace there. Well, from the first looks, I can see if I put 1, I will not get that, because this here will be positive, this will be positive, and I just have, I'll have 2 minus this big entire value. So I don't want to try 1. Now, if I try negative, negative 1, it won't give me also. Let's see if I try 2. So I want to try 2. Let me go with 2 first. So what is 2 cubed is what we're saying. 2 cubed. Yet again, you notice that it's going to give you something not yet. Let's try the negative first. So negative 2 cubed plus negative 2 squared minus 8 multiplied by negative minus 12. What does this give us? You multiply this, because of the negative sign, the negatives will be there because of, of the odd power. Get negative 8 here. And there, this will give you positive, so that'll be positive 4. This here gives you what? Positive 16. And you get minus what? Minus 12. Subtract this here, you get negative 4. Negative 4 can be added to this here, gives you negative 16. And you just get like 16 minus 16, which is what? 0. Yeah, so you can be looking at them and you can actually tell which one can give you. So we found out that, okay, the one that has given us is actually x equal to what? So these are the values of x. So it's x equal to negative 2 is the one which has given us a 0, which means if it's given us a 0, it's a factor of that polynomial function there. So if it's a factor, meaning what's the linear factor? The linear factor is what? Is just x plus 2. That's linear factor, and x minus 2 is what is the factor of that. So I can use that x, the negative 2. I'll use synthetic division, put my negative 2 here, and line up the coefficients of these here. So that's going to be 1 there, 1 there, and let me erase this here. Okay, so then what there? Then I'll get negative 8, then negative what? 12. So I'm going to factor this out, drop the 1, multiply by that negative 2. I get negative 2 here, add, get negative 1, multiply. I'll get a negative 2, a positive 2. Then I add this here, gives me negative what? Negative 6, multiply. I get a positive 12. And this here gives me 0. So this factors out to the quadratic, which is x squared minus x minus 6. So this is what I get. Now, next, I want to I want to get values from that. Okay, so let me erase this part and keep my values there on top. So remember, I've already found one of the intercepts, which is x equal to what? 2. Then now I have this function, or this, quadratic function now. So x minus 6. So I have this here. What do? I have to factor out this to get the other ones. So of course it's equating to 0. Uh, what do I do? So let me use product. So product is going to be multiply 1 by, that gives me negative 6. Sum is just negative what? 1. So I want to find, when I add, gives me negative 1. When I multiply, gives me negative 3. So those factors are just negative 3 and 2. That's what I get. So I can replace there, x squared minus, plus 2x, then minus 3x minus 6 equal to 0. So I get this, that. And this is x plus 2. Factor out what here? Factor out a 3. Then I get x plus 2 here. Meant negative 3 there. So this will give me x minus 3. And you have x plus 2 equal to 0. Then you get x here to equal to what? So x here, you get x equal to 3. And the other one will be x equal to what? Negative 2. So these are the values I get. I put them up here, x negative 2, and then I have x equal to 3. So now you must notice one thing here. You have a repeating what? Intercept. So now what you always must know is when you have a repeating intercept, like in our case here, it means that the graph does not cut the what? That curve does not cut. So if you have something like this, the curve will not cut the x-axis at negative 2. Let's say negative 2 is here. We don't expect the curve to cut. Instead, we expect the turning point to be at this exact point here. This is where the graph must turn from, then it must go something like that. So expect a graph like this. Always when you have two intercepts that are the same, the graph will not cut at that point. Instead, that same point will be the turning point of what? Of our graph. One of the turning points of our graph. Okay, I hope that's clear. Yeah, I don't know if there's any question so far. If there's any question. Are we still together? Okay, so what next now? Next, I must see how does this graph kind of behave? How am I going to what? How am I going to graph this? So in order to graph this and also in order to get our turning points, what you must do is find you must differentiate this function. So find f what? F prime, or in this case it's y prime. So we differentiate by power rule. I think you remember. So what do we do? Power rule here. What do we get when we differentiate x to the power 3? So we get 3x to the power 2. So remember power rule. What you do, you drop this power, then your x there, you do what? You subtract it minus 1, right? Remember this? We are clear now?
Yes. Yes.
Okay. So that's what we do. The next, we do the same. So we just get 2x there. And there we just get negative 8. A constant always gives you 0. So this is what we get here when we differentiate. Now, again, what I want to do here is to factorize this and get my critical points. So I'll call them critical points or critical values, whatever. But the purpose of me getting those values is just to show me the behavior of my graph. Okay. So what do I do? I have to factorize this. So 3 here. I factor out a 3 such that I remain with x squared. Then I have a plus what? This here is going to be 2 over what? 3x. And as I said, you can factor out this were not included. I don't want to include it. So I just put it here. Then what do I do next? 3 here. Okay, yeah. So I have 3 here. Then I can factor out inside. Remember, so I get my x, then half this. So what's half of 2 over 3? So I have 2 over 3, then I'm halving what? 2 over 3, like that. So you see, I just remain with what? Like 1 over 3. Yeah, 1 over 3, then I square. So the 1 over 3, I have to square it like this. So this will be minus whatever I square this, so that will be 1 squared over what? 9. So 1 over 9, like this, then minus 8. Okay, then I can multiply the 3. Then I get 3 here, x plus 1 over 3 squared. Multiply it by there. So what do I get when I multiply 3 over, I just get, I get 1 over 3 again, then minus what? I get minus 8 there. So to imply this, but then I know all this I want to equate to 0 such that I find my values of x. And so when I add, so those 1 over 3 minus 8, what do I get? This multiply there. 3 by negative 8 gives me negative 24. Yeah, and over 3. And this here will just give me negative 25 over 3. So I'll take it that side. So this will be x plus 1 over 3 squared. The negative becomes positive and it becomes 25 over what? Over 3. And then I can multiply both sides by 1 over 3. Multiply that by 1 over 3. Then, of course, I just get 25 over 9 on the right side. So on the left side, I remain with x plus 1 over 3 squared. Then this side, I'll just get 25 over 9. I invoke the root now, like that. Then I'll remain with x plus 1 over 3. And this will be equal to plus minus, and this is clearly 5 over 3. Then x, 1 over 3 can go that side, and I remain with negative 1 over 3 plus minus 5 over what? Over 3. And this is going to give me, so when I add, so I have negative 3 plus 5 over 3. So this gives me what? This gives me 4 over 3. Then when I subtract, I'll get negative, there are 5 over 3. And this gives me negative 6 over 3, which is just going to be negative 2. Negative 3, so yeah, negative 2. So are we together? Are we together on how we factored out and how we found those values?
Yes, I'm following.
Okay, so next, these are now what I'm using as my critical points. So I said x equal to this, x equal to that. So I'll line them up. The list is what? Is negative 2. Then the other one is 4 over what? Over 3. So what I check is from negative infinity there to positive infinity. So from negative infinity, or value is less than negative 2, what would be happening to my what? My graph. So I input my negative 2 into, no, I pick a value less than negative 2, and I input in my graph there. So let's say I put in negative 3, of course, and I'll have what in this y prime function? Negative 3, let's say 3. Negative 3 squared gives me a positive number, which is 9. Then there I'll have, I just have, okay, 2 minus 3 here, say negative 3, then 8. So what do we get here? So here we get 3 by 9 gives us what, 27. And this here gives us -6. -6 plus -8 gives us -14. Well, this gives us 3 there, then gives us 1. So this is positive. So what does that tell me? So that tells me in this region between -1 and this here, my graph is increasing. So it will be going like this. So this is how the graph should be going. So I expect it to come like this. Then I check in between here. Okay, so I check in between here, then what numbers are in between -2 and 3/2. I choose to pick 0. If I pick 0, I'll just remain with -8, and that's a negative number. So it shows me that my graph here will be decreasing like this. I pick another one number here, greater than this one here. Let's say I pick 2. So 2, what do I get? 2 squared is 4. So I have 3 multiplied by 4 plus 2 multiplied by what? 2, then -8. So this here gives me 12 plus 4 minus 8. And this will be 16 minus what? And gives me 8. It's a positive. So my graph will be what? Increasing in this what lane like this. So remember this graph. This is a very going to be keen in our calculation. Well, after finding that, so I'll write my critical points or values here. Just write them here because I want to erase this part. Okay. Now, something else that I have to do is to get turning points. How I get my turning points is, so these values I found, x -2 and x, the critical values. So I'll get 1, then I replace now in the function y, I replace where there's what, there's x. So I replace this -2 in the function, this original function here, to find my turning, the other coordinate for the turning point, which will be, so negative cubed there as -2 squared minus 8 multiplied by -2 minus 12. Then here, what do I get? This gives me -8. This gives me plus 4. This gives me plus that's 16 minus 12. And this just gives me 0, as I saw in the beginning. So this is one of the turning points. One of the turning points. So 1 we have. And let's do the other one. Okay, the other one. So we do the same. We get the 4/3, and I put it here. 4/3 cubed plus 4/3 squared minus 8 multiplied by 4/3, then minus 12. Okay, what do I get? 4/3 cubed. So what is 4/4/4? That's 16 by 4 is 64 over 27, right? Then I have what? 16 over 9. And that's 8 by 4. That's feels like
This
it.
one
Huh?
was then 32.
Or 32 over 3, then minus 12. Okay, so what do we get when we add all this together? When we add all this together, I wish I carried my calculator. I would have done this so fast. Okay, but still, let's do it. So we know now the common divisor is just what? 27. There it's gonna be 1 multiplied by that, I get 64. There it's 3 by 16. What's 3 by 16? 3 by 16. Do that quickly.
That's 48.
Okay, 48, so that'll be plus 48. Then 3 into this gives me 9, 9 by 32. What do I get?
288.
288, so this will be minus 288. Then 1 there, 27, 27 minus 27 multiplied by 12. What do I get? That should give me
324.
324. Okay, so I need to add these all together on top where I'm adding. So I'm adding, let me add my 64. Add 64 plus 48, you get 112. Then add these also. So you get 288 plus 224. That gives you 612. Then you subtract the 2. Okay, so 112 minus 612 gives you 500. This is over 27. So you get negative 500 over 27. Can we simplify this further on? Do you have any common divisors want to use there? Can we? Are we able?
I can't think of any number.
Okay, I also can't think of any number. But when we divide that, that is approximately, so that value is approximately like negative 18.5 something, going that way, yeah, something like that. So key, okay. So I can erase this now, and yeah, all this. And I think that has given me my second turning point, which is when I plug in 4 over 3, I expect to get a negative what? 500 over 27, like that. Now I can plot that. Okay. Can plot that here. So I have y and I have what? X. So, oh, we forgot about the y-intercept. Y-intercept just when when x is 0, we plug in 0 there, we just have y equal to what? Negative 12. That's our y-intercept. So the graph is cutting there at y. So remember, from negative infinity here to what? To that point where we said it was 2, or negative 2, I mean, the graph is what? Increasing. And the turning point is negative 2, 0. So meaning it's turning at that exact point. So there we see the graph is increasing and it will turn from there. Now remember what I said in the beginning, because we have two intercepts that are the two x-intercepts that are the same, two x-intercepts that are the same, we expect the graph not to pass through the negative 2, but instead it will turn at that point, and we see our turning point even agrees with that. The next, we want to go, so to cut at 12. So this is just an approximation. So say that point there is our what? Our 12. Our 12. Okay, yes. So let's say that's our 12, our negative 12, I mean. That then where do we expect the other one to go? So the graph is cutting at what? At 3. It has to pass through 3. Then what is my turning point? Okay, so should not forget the turning point is we have 4 divided by 3. That's like 1 point something. Okay, let me just go back a bit. Yeah, here. So yes, it has gone through that point, and we're saying that point is 12. But expect it to go a bit what? A bit lower. Okay, so now because I can't really draw up to a point where I'm saying that point is negative 18, but I think you get. So if I say this point here is negative 18, meaning my graph is going to turn from there. So this point here and that point there is what I'm calling to be my 4/3. So it will turn from there like that. Then it will go all the way. Pardon my sketch, but yeah, I think you get. It's going to go the way, then cut there where we're saying this here is our x equal to what? To 3, where it's cut, and that point there. So this here, that's the turning point where we're saying 4/3, comma negative 500/27, like that. So this here, this point meaning is our negative 500 over what? 27. Then like that. And as we said, how our graph was behaving from negative infinity to -2, it was increasing. Between these 2 points, it was decreasing. As you can see, it's decreasing between -2 and 4/3. Then from there to up to infinity, it's increasing like that. So you have something like this. This is how your graph will look, unless there's any question on how to graph the cubic function, but this is how you graph the cubic function.
I think I'm okay.
Okay, so that's how we graph this one. Let me just